Thank you very much. So my name is Jim Hall. We're actually going to do, this is a 2-for-1 session. So I'm going to cover this topic around why does your PC only have 16 colors? That talk takes about 10-15 minutes. And then there's another talk I'm going to do, which is the history of spreadsheets. So those of you who are interested in that, there's a bonus presentation for you at the end here. Just to get into the introduction, so my name is Jim Hall, and I'm the founder and project coordinator of the Freedos project. And you can visit us at freedos.org. And obviously, being involved in an operating system like Freedos, which is representing or reproducing an old PC operating system called DOS, MS-DOS, from the 1980s into the 1990s, obviously you might guess I'm kind of into retro technology. And so that's what this talk is about. And if you've ever wondered why your PC, why when you bring up like a GNOME terminal, why you're only getting 16 text colors and 8 background colors, right? These colors you might see here if you actually boot your computer into regular text mode. If you've ever wondered why you only have 16 text colors and 8 background colors, this presentation is for you. Because why is that? Well, it's because of history. And it all dates back to decisions made by IBM back in 1981. That's when the original IBM PC, personal computer, 5150 hit the market. And shortly thereafter, IBM released the IBM Color Graphics Adapter. The first version was only monochrome, but then they released the Color Graphics Adapter. And it turns out, and by the way, also the IBM Color Display 5153. And so the decisions that were made when we defined CGA back in 1981 are echoing back today. And that's why we're stuck with these 16 text colors and these 8 background colors. So we're going to require a little bit of knowledge of binary. And so I'm going to just do a brief primer here on binary if you haven't seen it before. So binary is all about on or off, right? And so you might represent that as sort of a light bulb being on or off. And each one of those on and off is actually a bit. And computers like to count at what are called bytes. And so bytes is 8 bits at a time. That's important later. And you can count up these different bits, right? They go up by 2s. And so you've got on the right-hand side, you've got a 1s column, a 2s column, a 4s column, an 8 column, and so on and so forth. And then, you just sort of count the bits that are in there. So that first row, just one light lit up, that is the number 1 because it only has a light bulb in the 1 column. The second one has a light bulb in the 2 column, and so that's our number 2. The third one has a light in the 2 and the 1 column, and that means that 2 + 1 = 3, and so on down the line. That's how binary counting works. But we don't usually represent them actually as light bulbs and blank spaces. We actually like to use 1s and 0s. And so this is the same thing represented as 1s and 0s. And so if you have a 1 in the 2 and the 1s column, then 2 + 1 = 3. And so that's how we count in binary. And that's going to be important as we go along. Well, why is this on and off, this binary important with color? Well, because it turns out there's, you can actually represent color through 3, at least in light, through 3 primary colors: red, green, and blue. And so if I only have, obviously red lit up, then I'm going to get red. But if I have all 3 of them lit up, red, green, and blue, I actually get white. And of course, if I have none of them lit up, I get black. And that's actually how those old CRTs actually work. On the right-hand side, you can see a representation. They would have these little clusters of what are called phosphor dots. And the CRT would light up each one of those dots at a specific time in a specific combination. And that would allow you to get combinations of red, green, and blue. And so each square represents a pixel. And so you got a grouping of red, green, blue, and that is 1 pixel. So if we light all 3 of those pixels up, then we get a white dot on the screen. And if we only light up the red dot, then we only have a red dot on the screen, right? So that's how we do color. And we're still doing color today. If you're going to zoom in on your LCD monitor, your modern monitor, you're going to get the same combination of red, green, and blue. And so that, color has not changed, right? How we represent color has not changed. And it turns out we can then represent a simple combination of color, red, green, and blue, by saying if I have the light on or if the light off, then I can represent color in different ways, right? If I have 0, 0, 0, it would represent that red, green, and blue are turned off. 0, 0, 1 means that of the red, green, and blue, only the blue one is turned on, right? So I've got, that's why I'm getting a blue color. Further on down the line, if I have, red and green turned on, 1, 1, 0, but I don't have blue turned on, then I'm going to get a yellow color. And if I have all of them turned on, 1, 1, 1, that means I've got a bright white color. And so I can get actually 8 colors this way, black all the way down to white, just using those 3 bits, making that simple assumption. But IBM's full of smart people, right? IBM figured out we can actually double the colors if we add an extra bit. And so in that extra bit, they said, what we're going to do is we're going to have an extra bit that's brightness. And so now instead of just having a red, green, and blue bit, we're actually going to do an intensity bit before that. So it's instead of just RGB, we actually are representing color as IRGB. And so on the left-hand side, you might say, okay, well, in the simplest case, we might say if that intensity bit is 0, then we're going to just run it at some low intensity color, like maybe like half brightness or something. And on the right-hand side, if that brightness bit, intensity bit is turned on, then I'm going to run all those dots at full color. And that's why I've got, for example, 0, 0, 1, 0, the third line down. On the left-hand side, it's sort of a half intensity green. It's not very bright, but on the right-hand side, 1, 0, 1, 0, that's full brightness for that green. And so you might say, you know what? All right, we're done, right? Mission accomplished. I can represent 16 colors up here. I've got, low intensity color on the left, and I got bright intensity color on the right, except, oh shoot, we have a problem on this one, because you might notice that while I can do low intensity and high intensity, black 0, 0, 0, 0 black is the same as 1, 0, 0, 0 bright black, because in both of those cases, I don't have any colors lit up, and that's always going to be the same. So I actually only have 15 colors here. And IBM said, okay, we can actually work around that. We're going to create a modified IRGB representation. And so we're going to say in the low intensity colors, if I've got a 0 for that intensity bit, then for any of the red, green, and blue bits, if it's a 0, I'll just leave it off, right? I won't light up that color. And if it's an on, if it's a 1, then I'm going to bring that to like a 2/3 brightness, we'll say, like, because we can do like 0, 1/3, 2/3, and full brightness. That's pretty easy to do on a CRT display. So I can do that. And so we can say if it's a 1 in the low intensity, that'll be a 2/3 brightness. And at the high intensity brightness, right, if it's a 1 for that intensity, then for the red, green, and blue, if it's a 0 for the red, green, or blue, I'm going to bring that actually to a 1/3 brightness, right? The lowest brightness that I can get without it actually being off. And if it's a 1, I'm going to bring it to like full brightness, right? And that way I'm solving the problem where I have, black and bright black being the same color, because now 0, 0, 0, 0 is a different color than 1, 0, 0, 0, right? And so over here, I've now got 16 colors. I now have solved the problem of black and bright black being the same color. I've adjusted my colors a little bit for low intensity and high intensity. And I could say, you know what, we're done. We can actually represent all the colors of the rainbow, right? I can represent everything up there. I can sort of fake it on the blue, indigo, and violet. And the other colors, I have colors for those. Oh, shoot. Actually, as I'm looking at that, I don't, because back on this page, there's no orange, right? Back here, I don't have an orange over there. There was no mixture of orange. So how do we get orange back? I want to be able to represent the rainbow. So IBM said, okay, we'll do one more fix on this one. We're going to say, okay, for that low intensity yellow color, where it was 0, 1, 1, 0, we're going to set green to be a 1/3 value. We're going to give it a different value on green. And so that will change the yellow from a yellow color to more of an orange color. And so that actually solves the problem with why do you have the orange color in there, and why does it look that way? Because they're representing that low intensity yellow and they're turning it into an orange color. Although IBM's got to mess that up somewhere. They're bright people, but they had to mess it up somewhere. And so if you look at any of the color references, you'll see a mixture. Some of the references say orange and some of them say brown, because it does look a little bit brown on a monitor. But this is actually where the 16 colors come from, right? I've got black, blue, green, cyan, red, magenta, brown, and white on the left-hand side for the low intensity colors. And the right, I've got the bright black, right? That's why we have a bright black, bright blue, bright green, bright cyan, bright red, bright magenta, yellow, and then a bright white. That's why we have those 16 colors, and that's why they look the way they do. But you're probably wondering, okay, that answers the 16 colors, but why do we only have 8 background colors? Which actually, if you look at it, they're always the low intensity colors on the left-hand side for background colors. Why 16 foreground colors and only 8 background colors? Well, it's actually because you need to look at the bit pattern. So remember I said that computers like to count, they count with ones and zeros, but they like to group them all together as all those bits into 8 bits for a byte. And so we need to look at the bit pattern. And so obviously the 16 colors, we're representing that with 4 bits, right? Foreground, 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 foreground. And that's using the lowest 4 bytes or bits in a byte. And then with only 8 background colors, well, obviously we're not using the intensity bits. So that's actually, we're only using 3 bits then for the background color. And so why 3 bits of the background color? Because I needed that extra bit, that last bit for something else. And it's the most important part of any text-based user interface. And those of you who write programs for character mode know what I'm talking about. It's the friendly blinking bit, right? And so it's the ability to blink text on the screen, because we have to capture that somewhere. And that, by the way, is why on certain systems back in the 90s, you had a program that might be able to tweak your VGA card to turn background colors into bright background colors. And it was doing that by repurposing that blink bit. And so if you did that, your text probably wouldn't blink. And so you'll notice that we've got 8 bits in here representing color all at one time, 4 bits for the foreground, 3 bits for the background, and 1 bit for the blinking bit. And that is 8 bits. That's a full byte. And IBM stopped there. That's why we have 16 text colors and 8 background colors. And for right now, I'm going to go ahead and pause and see if we have any questions about colors in text mode. And if we don't have questions, I'll move on to the next presentation, but I'll pause here for questions. All right, so I'm not seeing questions, so I'll go ahead and move on to the other presentation today, which is a brief history of spreadsheets. And so this is something that I have as a personal sort of hobby of mine, an interest of mine, is why do spreadsheets look and act the way they do? I teach, for example, in management information systems outside of my other work, and in that class, our students learn how to use spreadsheets. And the question always comes up, why does a spreadsheet look and act that way? It's different from all other kinds of programs. And so, if you look at, of course, there's my background information, but you know who I am from the previous presentations. But, why does, for example, LibreOffice look and act that way, right? If you bring up LibreOffice, you've got a window that looks kind of like this, right? You've got columns and rows. And where a column and a row meet, you have a cell. And the columns are labeled by letter, right? So you've got columns like A, B, C, D. And then you've got rows starting at 1 going all the way down, right? And so you can different spreadsheets will have different amounts of rows and columns, but basically you can have lots of different rows and lots of different columns. Well, why are we using the letters for columns and the numbers for rows? And by the way, that means that an individual cell, like the upper left-hand corner, which is where the cursor is on this one, is at the cell A1, because we use the letter and then the number. So why did LibreOffice choose this? Well, it's actually not just LibreOffice, right? You go to any other spreadsheet, they're doing the same thing today, right? So you look at, for example, Google Sheets. They do the same thing. They have a grid, and they have letters for columns, and they have numbers for rows. And that first column in the upper left-hand corner is cell A1. And so why does it do that? And sort of the naive answer might be, well, that's because that's how Excel does it, right? Here's an Excel spreadsheet, and Excel is again, got letters for columns, and it's got numbers for rows, and the upper left-hand cell is A1 because we're addressing all of these cells as letter and then number. So why do we have spreadsheets that look like this? Well, it's actually because of history. And so you know, when you look at how spreadsheets kind of came to be, right? The first spreadsheets were actually on paper. So the first spreadsheets were written on paper, and or they were done on chalkboards. But you had a spreadsheet. This is actually a piece of paper spreadsheet you can actually even buy today. And you'll notice that it's got columns and it's got rows, and you can write numbers in each one of those cells or boxes where a column and a row meet. And you've got, they're numbered by column, and they're numbered by row because there's no other reason you wouldn't do anything else like that. And this is where people would perform certain kinds of calculations. And so in this case, this might be a paper, piece of paper that somebody might use to calculate their expense report going somewhere. And so you can see that you can now add up the different numbers. And those lines provide a very convenient way to track the numbers, columns, and even hundreds and thousands and things like that. So that's kind of the original story for why spreadsheets are certainly columns and rows. But it gets better than that, because back in the 1960s, it's like, why are we using paper, right? So why are we using paper? We're smart people. We got computers at this point. We can have computers do the hard work for us. Computers are very good at dealing in numbers. And, but the problem is that if you had, like, for example, Bell Canada had, had budget spreadsheets or budget programs, rather, that they would run. And the problem was that if you needed to make some changes to that budget program, in terms of numbers you might be able to put in, the calculations that happen based on those numbers that go in, the programming team would tell you, well, we're going to need 6 months to make a change to that budget sheet, to that budget program. And that's a long time when you think about it. 6 months, that's a long time. I mean, assumptions in your base budget might change over 6 months. And for a very large change, the report, the analysis came back and said, this will be a 2-year change. This will take 2 years to make this kind of a change in the budget system. Well, 2 years is huge, right? That's 2 fiscal years going by. So Rene Pardo worked at Bell Canada. And he had this great idea, talking with his friend, Remy Landau, that, why don't we just let the computers do the work for us? Let somebody put in the calculations that they would need to do their budget, and let that manager do the work on their own. And Remy turned to him and said, what you've basically done is you've created a programming language, which actually he had done. He actually had defined a way to define rows, or what were called lines, and then these columns, and then where each line and column meets, you've got a box. And I know that what we're seeing here on screen is a little bit blurry, but I'm gonna do an actual example here where you can see things a little bit more detail. But this is the first spreadsheet program called LANPAR. And LANPAR ran on Big Iron Systems. It was a time-sharing system. And so again, the concept is you got these columns that are out there. And in this case, I've got a simple example. I just have 3 columns and 3 rows, right? So you can see column 1, 2, and 3, and I've got line 1, 2, and 3. And where each one meet, I have a box. And so the first box in the upper left-hand corner is, that's at line 1, column 1, or box 101, right? That's the coordinate. So basically you got the line number, and then you've got the column number as a 2-digit 0-padded value. And so you can always figure out what the column and line is based on the box number. So I know that, for example, the second line down and the third column over is going to be 203, right? That's second line, third column, 0-padded 2-digit column number. And you can have up to 99 columns and 999 lines in a LANPAR spreadsheet. That actually comes from the patent application. And so the way that you would run calculations with this is, for example, you might do something like this, where you say, I need to generate maybe a report over 2 quarters, where I say I need to generate, understand the revenues that we've generated. And so that's going to depend on, so I'm going to calculate the revenue, and each line in the revenue is going to be the units that I've sold times the unit price. And what's really powerful about this that you might not notice by looking at this right away is forward referencing. This was the power of LandPAR in 1969, the concept of forward referencing. I've got a calculation up there in box 101 that's dependent on things that are happening over in 102 and 103, things that the spreadsheet hasn't even seen yet. It has to go over and look for it. And so it has an ability to run through the spreadsheet, the whole entire thing, to work out all the different calculations that need to happen and all the different in the correct order to be able to generate output. Each one of those boxes, by the way, can hold a constant, which is going to put in with a K to indicate that that's a constant, or it can request input from the user in some way. So it might come from a file, or the user might insert a card, a punched card, or some other way to provide input to the system, or it can be a calculation, or it could be an empty box. And so, with this concept, with the initially simple, you can create very complicated calculations. And in fact, there's a story that a manager that would have required, waiting 2 years for that budget program to get updated, could put this together over a weekend using calculations that they would find natural, and all they have to do is get it into the computer somehow. And so you might put that in through punched cards. Actually, this is just a representation of what you might put in for punched cards. These aren't actual LandPAR punch cards. And in fact, I realized after I put this slide together that there's some stuff missing at the front of the line. But basically, this is what you're putting into the system. You're separating your your box references, your calculations or inputs or constants with a semicolon, right? That's the delineator between these different boxes. And so that allows you to put in data into LandPAR in a very human, natural way. My parallel for LandPAR is that it's very similar to, let's say, NROF or LaTeX, right? Where you take a source file and then you run it through NROF, or you run it through LaTeX, and LaTeX processes that file and generates an output file. And that's what's happening with LandPAR. You run your input spreadsheet, and then it does all the calculations and generates some output. And actually, it's even closer to LaTeX than you might think, because LaTeX generates not a print file, but it generates a device independent file. So basically generates an intermediate file. And there's a separate program in LandPAR that would actually take the output from LandPAR and it would generate something that you might print out. And so that was LandPAR, 1969. Unfortunately, it was too early for its time. I mean, this ran on 32 kilobyte memory systems. It was a timeshare system. That was back when systems cost maybe $100,000 per month to get time on the system. And it wasn't something that just anybody had. It was pretty specialized equipment, although pretty widely used. It was still kind of considered specialized equipment. And so there were other ways that it took a little while rather before we got the concept of the spreadsheet that we see now. And in fact, by that time it had changed its shape a little bit, because around 1979, I think the year was 78 or 79, there was Dan Bricklin working at, he was an MBA student. And the story goes that he was watching his instructor run calculations on the chalkboard, because that's what you had to do, right? So you had to run stuff on the chalkboard and running through these different calculations. And then if the instructor made a mistake in one of the earlier calculations, he had to go back and erase all the stuff that had happened since then, and then do all the calculations back from scratch. And so the story goes from Dan Bricklin that, we could actually have a computer do that, right? Why not have a computer do that? Well, what was the most popular desktop computer at the time, right? This is 1979. We had the Apple II computer. And so that's actually what happened, is that Dan Bricklin, I'm skipping over some details here, but Dan Bricklin created this program here. This is visicalc. And this is the first spreadsheet for personal computers, microcomputers that you might have in your home. And a lot of people had Apple IIs, by the way, in their home. I did. And what did Dan do in this program? Well, he again, he picked letters for the columns, and he picked numbers for the rows. And why did he do that? Well, he says, I need to be able to reference a cell. And so how do I reference the cell in this case? Well, the cell's a reference of the column letter and the row number, right? And so that's how he chose that he was going to reference these different cells. And he had a limited selection of functions that he could do in terms of sums and averages and things like that, right? So basic mathematics that you could use in, for example, an MBA course. The problem with visicalc was that it didn't have forward referencing, right? So we had forward referencing before. We had forward referencing under LandPAR, but this was a different thing, and it didn't have that forward referencing. And so if you were running a large spreadsheet through visicalc, then you actually might have to recalculate. There was a key that you could hit to recalculate, and you might have to recalculate a couple of times until the numbers stopped changing after you updated the data, and that meant that your thing was done. So because it didn't have forward referencing, you had to manually recalculate all the time, and that was something kind of people got used to. They kind of get used to just typing in their spreadsheets, and they kind of got used to putting the calculations on the right-hand side or on the bottom, and that kind of got away from the issue of the lack of forward referencing. And in fact, I tend to, even today, will put in calculations on the right or on the bottom, just because that's how I grew up. Now I can talk about visicalc, and I've got spreadsheets, or I've got screenshots rather for visicalc. I got over here, for example, a screenshot of visicalc running on DOS, because it did get updated for DOS in 1981. But I'm from the Freedos project, and I've got a virtual machine over here that runs Freedos, and it's got some spreadsheet programs on it. So let's go ahead and bring up, here is a virtual machine running Freedos. And if I go into my VC directory where I've got a copy of visicalc, right there's visicalc. And so I can do simple calculations on here. So I might just do, for example, in my, I mentioned I'm in teaching an MIS class, Management Information Systems class. And in that class, we might say we've got, certain quizzes that happen every week. And so I've got quiz 1 in here. I've got quiz 2 in here. Just so you're not writing quiz all the time, I'll say 3, 4, 5, 6, 7, 8, 9. Say we have 9 different quizzes going on. And then for each one, I might want to indicate the possible points that you could get for that. And in this case, it's 5 points for every quiz. And then I might, as a student, put in my actual score. And students are doing pretty well on that. They're either getting 4s or 5s. And so we'll just put in some 4s and 5s in here. Oops. And I also have every week some exams. And so I've got an online exam that happens, exam 1, exam 2, 3, 4, 5, 6, 7, 8, 9. My possible points for those, well, they're all 10 points. I don't want to keep typing 10 all the time, so I'm going to actually replicate that using / to go into the menu, R to replicate. I'm going to replicate from F3. And I'm going to push it all the way down to F4 ... to F11. That's how I did ranges back then, was ... And you can see I've now replicated the value of 10. And those students are doing pretty well. Let's say that the student is getting a mixes of 8s and 9s, mostly 8s. And that's what they're doing for the exams. We also have 3 outside assignments, by the way. And so they had to do a formatting assignment. They had to do a spreadsheet assignment. And later on, they'll do a paper at the end of the semester. And so it's 100 points for each one of those assignments. And so let's say a student does 98 in the first one, maybe 89 in the second one, they do 91 in the third one. And so as a student, I could say, okay, well, I could calculate the sum of all the possible points. And so that's going to be B3 ... down to B15. I know I've got a blank line in there, but that's okay. It'll take care of that. And then also, comma, I'm going to add up F3 ... down to F11. And so there's the total points for this class is 435. And I'm going to replicate that from B17 over to C17. And it's going to ask me, do I want to keep the values, these cell references themselves, or make it relative. So it's going to shift over by 1. And I'm going to say relative for each one of those values. And so this student is doing 393 points at the end of the semester. And that means they can do a calculation of C17 divided by B17. We're going to multiply it times 100 to make it look like a percentage. And so that student is getting bottom of an A, right? So they're doing pretty well. And so that's how spreadsheets worked in 1979 to 1981 or so. Well, why aren't we still using visicalc? Well, visicalc, as I said, didn't do forward referencing. It was also limited in some other ways. And so Lotus Corporation came along. So I'm going to quit this. And Lotus came along and they created a program called Lotus 123. And it was called 123 because it did 3 different things. But really the thing that people really want to look at is the spreadsheet. And so here's the Lotus 123 spreadsheet. Again, it had, now this is the first one that we had on DOS that could do forward referencing, something that had been invented originally with LandPower, but now we can do it on a DOS spreadsheet. But also, gosh, it looks an awful lot like visicalc, right? We've got letters for the columns. We have numbers for the rows. And in fact, the first column, the first cell that I'm in the upper left is column A, row 1, or cell A1. So it actually, Lotus 123 intentionally used the same kind of cell addressing that you would use in visicalc. They use the same functions that you would use in visicalc. You notice I put an @ in front of a function name in visicalc, and so they did the same thing in Lotus 123. And you could do calculations like, let's just say I've got a standard business thing, and I might want to do a calculation of my revenue, and I'm going to do that based on the number of units sold, and then the unit price. And let's just say each calculation here is going to be, B2 times C2, right? So that's going to be a forward reference here. So right now those are blank, so I get 0, and I'm going to go ahead and copy that cell. Slash is how I get into the menu. I'm going to go ahead and copy that from A2 down to A3 down to, let's just say, A10. Let's just go down there. And so then as I put in my quantities, and so maybe I sold, only a couple at the beginning, but I can walk my way up to selling 8 or 9 the rest of those, let's say, weeks. And then what's the unit price for this? Well, it might be maybe $1,200 for a unit price. And again, I could copy that by going from C2 to C2 down to C3 to C10, except maybe these last 2 months, I'm going to change those to 1,300. And again, we're seeing forward reference in action. So over here, we've got this calculation that's being made on some data that's off to the right. And every time I now updated my quantity or my price, it was able to update the calculation of the revenue. And, so this forward referencing was a huge distinguishing feature in Lotus 123 that visicalc did not have, but I also, as I said, it also had some other features. And so basically, Lotus 123 was I would say, a better visicalc than visicalc. And because it used the same cell addressing, A1, it used the same functions, you didn't have to relearn basically how to use a spreadsheet, how to go from visicalc to Lotus 123. All the skills that you had about building spreadsheets with visicalc just ported over immediately to Lotus 123. There's some differences in terms of the menus, but gosh, how to use the spreadsheet, you didn't have to relearn any of that. And so because it made that on-ramp easy, and it was more powerful than visicalc, Lotus 123 really took the market. And in fact, there were other spreadsheets out there as well. I'm not saying that, Lotus 123 and visicalc were the only ones. You had other ones like Multiplan from Microsoft, but they used a completely different cell reference model. And so the fact that, visicalc was so popular, and by the way, I forgot to mention that you had businesses that were buying Apple II computers just to run visicalc so they could do calculations on their own without having to go through a programming department. And then when the PC came out, they switched over to Lotus 123. Yeah, other software manufacturers noticed that, and they made competing spreadsheet programs. And as I said, some of them chose different ways to address cells, and so they weren't as popular because, gosh, you kind of had to relearn how to do a spreadsheet. But my favorite spreadsheet at the time was actually As Easy As. And so if you've used As Easy As, This is going to mess up my video, so I have to make this small again and make it big again. It looks very similar to Lotus 1, 2, 3. I've got letters for my columns. I've got numbers for my rows. And again, I'm referencing each cell by a letter and a number. So the one that I'm in the upper left-hand corner is A1. Trius, which is the manufacturer for As Easy As, actually focused on making this more for engineering. And so it had some great features for engineers, or some defaults rather, that made it easier for engineers. But it was otherwise compatible with Lotus 1, 2, 3. In fact, it would still read the same source files. I was a physics student as an undergraduate, and I would often put in, like let's say an XY chart. And so I might put in a value of, like, let's just do like 1, 2, 3, 4, 5, 6, and then numbers that look kind of linear. So it might be like a 1.05 and a 1.99 and a 3.02 and a 4.11 and a 4.97, and we'll do one more here. We'll do like a 6.02, right? And so there's my line data, and you can chart this. But one other thing you'd really do, which you could do under Lotus as well, but something I did in As Easy As a ton, was again going to the menu with slash, right? You're using the same way. I do a linear regression, so I can do my data, and I could do a linear regression. And so my X data is over here from A2 down to A6. My Y data is over here from B2 down to, I'm sorry, I said A6, I was really A7. And there's my Y data, and then I can generate my output, which will do a line fit. And so now I can see that I've got, by the way, an intercept on this line, which is 0.038666, but it's really plus or minus 0.05. So really that's a zero intercept, which looks right because I'm doing a standard XY line. And then the slope is almost 1.996 and some stuff, but it's actually plus or minus 0.01. So actually I've got a line here that's a slope of 1 and an intercept of 0. And so for me anyway, this was a great spreadsheet program, and a lot of people that worked in engineering that I've spoken to also ended up using As Easy As. But what really took away the market, by the way, from Lotus 1, 2, 3, As Easy As did not steal the market. They took some of it, but they didn't steal the whole thing. It was really another program called Quattro Pro. And so Quattro, again, it's going to flip into graphics once I need to make this small and big again. Quattro Pro was a more advanced spreadsheet than Lotus 1, 2, 3. What one of the major features was, it was no longer running a character mode, right? We were running in a WYSIWYG mode. But otherwise, look at this. This is using letters for columns, and it's using numbers for rows. And the cell addressing is, A1. All the functions are the same thing as Easy As, the same thing as Lotus 1, 2, 3, the same thing as visicalc. And so if I were a Lotus 1, 2, 3 user, I didn't really have to relearn how to do spreadsheets to move from Lotus 1, 2, 3 to move over to Quattro Pro. And so I could do the same kind of calculation that we were doing before in Lotus 1, 2, 3. I could say my revenue is over here, my quantity sold is over here, and then my unit cost is over here, my unit price rather is over here. And so I could do a calculation that says for each row it's going to be B2 times C2. And I'm going to go ahead and copy that from A2 down to let's just go down to A10. And the quantity, like I did before, we're going to walk ourselves up from, oops. We're going to walk ourselves up to 9, and then we'll sort of bounce around at the 8s and 9s. And the unit price is, let's say $1,200. And again, I'm going to copy that down to this range here. And so again, we're doing, see another example of forward referencing, and I'm able to calculate my revenue model based on these numbers. And again, it's the more powerful version of Lotus 1, 2, 3, and it actually did take the market from people at that time. So people were using, starting to switch over to Quattro Pro at that point. But Quattro Pro didn't really hold on to the market. So why didn't Quattro Pro hold on to the market? And that's because Microsoft, or rather Apple, I take that back. Apple was working on a new platform called the Macintosh. And so the Macintosh came out in 1984, and Steve Jobs recognized he needed to have applications ready to go for the Macintosh for people to be able to use it. And so he worked with Microsoft to create an Office suite for the Macintosh. And so in 1985, you had the first Microsoft sort of Office compilation for the Macintosh, which included, among other things, a spreadsheet. And so, Microsoft had done multi-plan before, and it didn't really work out because they had a different way of referencing these cells. But when they learned those lessons when they went to Excel on the Mac. And so you'll notice here, again, we've got columns being represented by letters, and we've got rows being represented by numbers. And each cell is a combination of the letter and the number. And so you got A1, B1, for example. And so that's why, so what they were trying to do is basically say, if you had used Quattro Pro or used Lotus 123, then moving over to Excel on the Mac is a pretty easy move to make. You don't have to relearn the spreadsheet. Yep, some of the menus are different, but in terms of using the spreadsheet, creating calculations on a spreadsheet, it's the same from all other spreadsheets that you probably had used that came before it. And of course, Excel didn't stay on the Mac. Microsoft eventually released a version of Excel for Windows, but that was Windows 2.0, not very popular at that point. And so it took a little while for them to release Windows 3 and then Windows 3.1 in the early 1990s. And that's really where Windows kind of took off, at least in the Office space. I'm not really a Windows fan, as you might guess, but that was really where it took off. And that's, again, same interface you got here on the Macintosh: letters for columns, numbers for rows. And if people were running Windows on their computer in the office, they probably didn't want to run DOS applications anymore. They wanted to run Windows applications. And so they didn't want to run Quattro Pro anymore. Quattro Pro didn't have a Windows version right away, so people were moving over to Excel. And so Excel kind of took the market at that point because of Windows. But it basically, Excel looked and acted the way it did because that's how Quattro Pro looked and acted. And Quattro Pro looked and acted that way because that's how As Easy As and Lotus 123 acted. And Lotus 123 looked and acted that way because that's how visicalc looked. And that brings us to full circle back to LibreOffice Calc. And so here I've got LibreOffice Calc. And again, letters for columns and numbers for rows. And I could do that same MIS calculation that we were doing before, where I've got these different quizzes. There's quiz 1, and I can actually click and drag this little box. That's a really neat innovation. And then I could have the maximum points, and that might be 5 for each one of my quizzes. And my score might be doing a bouncing around between 4s and 5s. And then I also have my exams. And then I've got these 10 different exams. And then each one of those is worth 10 points. And so I'm going to copy and paste my values there for 10. And then students are doing pretty well in those. Let's say I got a student here that's doing mostly 8s more than 9s. They have a formatting assignment that they need to do. They have a spreadsheet assignment that they need to do. At the end of the semester, they'll do a paper assignment. Each one of those is worth 100 points. And a student might do 98, they might do 89, and they might do 91. And so that means that the total score sum, right, the equal sign is what Excel introduced. That's where it changed from an at to an equal sign to do a calculation in the cell. And so that's the sum of this range, comma, this range. And then the student is actually, in terms of tracking their scores, getting 408. And that calculation is 408 divided by 450, which, if I turn that into a percentage, is bottom of the A's. So if you ever wondered why Excel or why LibreOffice Calc looks and acts the way that it does, why does a spreadsheet look and act the way that it does? Well, Calc is doing that because that's how Excel did it. And Excel did it because that's how Quattro Pro did it. Quattro Pro did it that way because that's how Lotus 1-2-3 did it. And Lotus 1-2-3 did it because that's how visicalc did it. So actually, in a way, you're kind of looking back at design decisions that were made in 1979 in visicalc that are still echoing with us today. But gosh, I do have to give a ton of credit to Landpar back in 1979 for that forward referencing. That is an important milestone in spreadsheets, and we wouldn't, I think, be where we are today without contributions from both of those programs. And so that's my brief history of spreadsheets. So I'll go ahead and pause there and go for questions. If anybody's got questions, you can go ahead and put it in the chat, and I'd be happy to answer your questions. Oh, and I saw, by the way, I see that we have some questions going on in the chat, but not the QA. So answering a question from earlier on the 2 palettes for CGA. And so there's a graphics issue there around CGA that they were picking a different way to represent colors. And so they had a limited color palette. And that was really coming down to the way that we were representing the bit patterns in CGA. If you're basically I think the short answer is, if you go back and look at how the bit patterns are being represented and how many bits you had per for color, that's actually going to tell you why we had the color palette that we had in CGA graphics mode, because you're talking about 300 by 200, and that's a graphics mode for CGA. And if just basically look at the bit patterns that we had for CGA back then. But by the way, since you mentioned palette, Tim, I'm also going to share that you're not always stuck with those colors that I mentioned, those 16 colors in the foreground and the 8 background colors. You're still stuck with 16 and 8, but you can actually change the palette on that. So certain VGA cards had an ability to change the text color, foreground and background. And so there were programs that would let you do that. And by the way, I see that Renee is in the chat as well. So say hi to Renee Pardo, the creator of the very first spreadsheet, Landpar. And thanks, Andre. Thanks, Crystal, for your comments there. Any other questions I can answer around color or history of spreadsheets? All right. Well, I'm happy to answer questions over email as well. And you've got my email from earlier in the presentation, jhall@freedos.org. So thank you very much. I'll hand it back to you.